Electric and gravitational fields. Electric and gravitational fields have the same form of equations representing their field strength and their force. So comparing the two here, first for field strength, an electric field, E, is given by 1 over 4 pi epsilon naught times the charge Q over the separation R squared. A gravitational field, G, is given by minus the gravitational constant big G multiplied by the mass m over the separation squared. So both are equal to a constant multiplied by the property concerned, be it charge or mass, divided by the distance from that charge or mass squared. The force for an electric field is given by 1 over 4 pi epsilon naught multiplied by the product of the two charges, Q1 times Q2, over their separation R squared. And for a gravitational field, the force is given by minus the gravitational constant multiplied by the product of the two masses, m1 times m2, again over their separation R squared. So here, both terms are equal to a constant, in this case 1 over 4 pi epsilon naught, in this case G, multiplied by the product of the two properties involved, charge or mass, and divided by the separation squared. They differ in that the gravitational force is always attractive, as shown by the minus sign here, whereas the electric force can be attractive if the charges have opposite signs, and repulsive if the charges have the same sign. This leads to electric forces mainly cancelling out, whereas gravitational forces always add. Also, the electric field constant is much greater than the gravitational constant. 1 over 4 pi epsilon naught has a value of 8.99 times 10 to the 9 farads to the minus 1 meters, whereas the gravitational constant G is 6.67 times 10 to the minus 11 newtons meters to the minus 2 kilograms to the minus 2. This means that quite small charges can produce significant fields and forces, whereas enormous masses are needed to produce significant fields and forces.